Okay, this is a setup video for the Circuit Basics lab. So what I'm going to do is show you the different items from your lab materials that you're going to use in this lab, what they do, how they all work, and then I'll kind of get you started with a little bit of how to set everything up. So there's a bunch of different little things you're going to do in this lab, but once you get the idea of how to set up one or two things, then you should be able to set up the rest from there. So, so here are all the items that you're going to be using for this lab. So the first one I want to point out to you is the breadboard. Okay, and so you'll notice with the breadboard that so the breadboard has kind of two main sections. So right down the middle there's this gap that separates the left side from the right. So what we're really going to focus on is the left side. So you can see here that there's 5 columns labeled A, B, C, D, E. Okay, and then there's 30 rows labeled 1 through 30. Okay, and so the way the breadboard works is that everything in row 1, all 5 of those holes, or we can call them ports, they're all connected. Okay, so maybe we could say that this is the first hole there under column A, row 1. We could call that port 1A. Okay, and then the B in the B column of row 1, we could call that B1. Okay, and then C1, D1, E1. Okay, so those are all connected. Okay, everything in row 1 is connected. Same for row 2. Everything is connected. Row 3. Everything's connected, and so on, all the way down through there, okay? So that's the main part of the breadboard that we're going to use in our labs. But just for your information, if you're curious, this other side of the board could be used. We see that we have the red plus column, okay? And there's, I think, 25 ports there, and everything in the column is connected, okay? So it's a little bit different from how columns A through E work, right? Because the ports in the columns aren't connected. The ports in the rows are connected, okay? So in the plus column, everything in that column is connected. Same with the green negative sign. All those holes, all those ports in its column are all connected, okay? And then the other side of the breadboard works exactly the same way. Okay, so depending on how much room you need, you may use one side or both sides, and that's basically how the breadboard works. Okay, so the next part I want to show you are what we call the jumper wires. Okay, so we gave you you should have some bunch of these jumper wires, and they just essentially have these little, they have like a little plastic covering on them, and then they have a little tip at the end. And these are nice because they can plug right into the ports. They're made to plug into the ports on the breadboard easily. Okay, so we have a bunch of those. You also have a couple of these other jumper wires. But that they have the little jumper end on one side, but the other end has what we call an alligator clip, okay? Because it looks like an alligator mouth, and that can be nice if you want to grab onto a device in the circuit, okay? So we're not going to use it for this lab, but I just wanted to show you what they were, so you know what was in your lab materials. Okay, so the breadboard and the jumper wires are basically how we're going to connect everything, make our circuits, and then we also have items in the circuits. So we're going to use some resistors in the circuits, and we have, for this one, we're going to use some 10,000 ohm resistors, and and some 1 ohm and a 1 ohm resistor. So they're in these little electrostatic baggies, and you can see that they have a label on them starting with the letters MPN. That stands for the manufacturer's product number. Okay, and so this is in the lab manual instructions too, but you see how it ends in J0103. Okay, that's the manufacturer's product number for the 10,000 ohm resistors that we're going to use. Okay, and then the 1 ohm resistors, okay, the MPN is labeled J0109. Okay, so just a 9 instead of a 1. That's how you can tell they're the 1 ohm resistors. Okay, and we also are going to use an LED in this lab, the red one, so you can tell it's red, so you don't have to worry about what the MPN number is. Okay, and resistor is, an LED is sort of, in some ways, a resistor, because it does resist the flow of current, but it doesn't really obey Ohm's law the same way, so it doesn't work exactly the same way. But so we're not going to do any kind of like calculations with the LEDs, but they are things. There are resistance. Okay, and technically your wires would have resistance too, because it's not perfect, right? But they're designed to have such little resistance that they're effectively zero resistance in a circuit. Okay, so we can kind of model them, treat them as if they don't have any resistance at all. Okay, same with the connections on the breadboard. All right, so for our power source, so we're going to light up the LED. We're going to send some power to the resistors. So our power source is going to be our iLab device. Okay, and so inside the iLab device, if you were to open this compartment here in the back to replace the batteries, you would see there's 2 AA batteries. So that's the source of our power. Okay, and the device is designed to output a very specific amount of voltage. Okay, and so that's what you're going to see here in the beginning parts of this lab. And so you know that a battery has a positive end and a negative end, right? So if you look at my AA battery here, right, you know the positive end, right, it'll have a plus there and it has a little bump on the end, and then the negative end, okay, is sort of more of a flat, more flat there. Okay, so you know one's positive, one's negative, and so essentially what corresponds to the positive end of our battery source in the iLab device are these 3.3 volt ports. Okay, so there's 2 of them, so you can use either one of them. They'll do the same thing, but they correspond to the positive end. Okay, and then any of these ones that say GND, short for ground, okay, those will correspond to your negative end of your battery. Okay, and there's a few of them, so you can use any which one you want when you're making your connections. All right, so the first thing you're going to do in part 1 is you're going to just power up an LED. Okay, and so to do that, you can check out the pictures. We'll have a nice still image of what I'm going to try to show up to make the same setup for you here. But what I'm going to do is I'm going to take, you might have different colors, but it doesn't matter the colors, they all do the same thing. But what I'm going to do is I'm going to connect my red wire to one of the 3.3 volt ports. Okay, just pop it in there. And then I'm going to connect that on the breadboard to port A1. Okay. And then I'm going to take another one and I'm going to connect my black wire here for me. I'm going to plug it into one of the ground ports. then I'm going to connect that to row 9. Okay, and by doing that, that should give me enough room to spread out the LED. Okay, so I'll open up my bag here, get the LED out, and then LEDs have a positive and negative end. Okay, you can't just plug them in any which way. Okay, so it matters which way you plug it in. So the way you tell which one's positive and which one's negative so the way you tell which one's ends positive, which one's negative, is that the positive one, positive one has a longer end. Okay, so you can see one's shorter. It's back, so it's a little hard to see, but if I try to straighten that, you'll see one end is longer than the other. I'm really close together. Okay, so the longer end is the positive end. Okay, and so I'm just going to bend these wires a bit so I can make it so they'll get in the hole. And so I'll put the positive end next in the port here. I'm going to put it in C1. Okay, so I want the positive end to be connected to the positive end of my battery in the iLab device, and then the negative to the negative. Okay, so I'll put that in port C9. Okay, and if you got it backwards, that's okay. If it doesn't turn on, you could try flipping it the other way in case you accidentally put it in backwards, and then see if it lights up. So if you put it in backwards, it won't light up. All right, so now we're going to open up the iLab software. Okay, so I got my software open, I'm paired. So now if I turn it on, as soon as I turn it on, if everything's connected right, that LED should light up. Okay, and it does. Okay, so that's kind of your test to see whether or not you have everything hooked up right, everything's connected properly, and you can tell if you're on the right path or not. Okay, so just take a little picture of this for your lab report, to insert in your lab report. Just take a picture of it lit up, that way I know you figured it out. And then in part 2, basically what we're going to do is we're going to take out that red LED, and we're going to put in one of the 10,000 ohm resistors. Okay, so I don't have to turn anything off or anything, it's not going to hurt you. Just pop it out. And then the 10,000 ohms, I'm just going to double check here. I think they're the 0103. And I'll just double check. Yes, they are. I'll get one of those out. Okay. And pull them out of their tape. They come out easier than the LED did. Okay, and again, you could just bend the wires so that they'll go into whichever hole you want them to go into. So I'm trying to keep everything here in the video the same, put them all in the same ports as in the pictures in the document, just to kind of help you out there if you're getting confused. But really, you can put them in any ports you want. So that's up to you. You don't have to do it exactly the same spots as I do. The point is that we want one end of the resistor to be in the same row with the positive power, positive end of the battery power, and then the other end of the resistor to be in the negative, the same row as the negative end of the battery source. Okay, that's all that really we need to do. Okay, make sure that they're in the same rows. Okay, and unlike the LED, the resistor doesn't matter which way you hook it up. It doesn't have a positive or negative end. Doesn't matter. Right, and so now So the power is on, so power is going through that resistor right now. Okay, even though we didn't start up anything, open up any sensor on the iLab software, we still have power going on. We saw it that as soon as we turned the iLab device on, when we had the software open, then we saw that LED light up. So it's getting power automatically. Okay, so what you'll do with that then is in your software, what you're going to do is we're going to use what we call the analog 7 sensor. Okay, so it's the third sensor down on the list. And in order to use that sensor, basically this sensor measures the voltage passing through the circuit or through any part of the circuit. So in order to measure the voltage with this sensor, we're going to need another wire. So I'm going to use my green wire, and the analog 7 sensor corresponds to the A7 port on your iLab device. So I'll pop that in there, okay, to A7, and then I'll plug it in. You can plug it in anywhere into row 1. Okay, so in the picture I put it in 1E, port 1E. So I'll do the same thing here. Okay, and so the way this analog 7 sensor works is that it measures the voltage between the A7 port, okay, wherever we plug the A7 port into, wherever we connected that port to on the breadboard. It measures voltage from there to the ground. Okay, so by putting the A7 in row 1, connecting the A7 port to row 1 and the ground to row 9, right, just like the resistors connected in row 1 and row 9, we're measuring the voltage in between row 1 and 9. So basically, what we're measuring the voltage across that resistor. And sometimes we call that a voltage drop across the resistor. Okay, and so you can go ahead and click record and just let that record for a few seconds. I'll click stop, and then you should automatically be on the data collection mode, those 3 bars there. And just like in the first lab, we can click and drag, okay, to get an average. And so remember, the average is represented by the mu here. So I get about 3.2973 volts for me. You might be a little slightly different, it doesn't matter, but you should be pretty close to that. All right, so basically, since the A7 sensor measures voltage, basically the iLab device is our voltmeter, right? That analog 7 sensor is our voltmeter. Okay, so if you were to get into more electronics, you would probably use a multimeter, a device that would measure things like voltage, current, resistance, but we didn't send that to you because the iLab has these things in them already. And so what we'll do is we'll use the analog 7 sensor to measure voltage. Okay, so it's acting as a voltmeter, and you can see in your lab instructions in the lab manual, I do a little schematic diagram of what this would look like, this setup here on the breadboard with the iLab device, how we would symbolize it with a schematic diagram. Okay, and so make sure you're following your instructions detailed in there in case I missed something as I'm making this video. But the instructions tell you everything to do. The lab report is where you're going to put all of your responses. And so the last thing I want you to do in part 2 is calculate the current. Use Ohm's law to calculate the current going through this resistor. Okay, because you know the battery, you collected the battery power by taking the average, right? So for me, it was 3.2973 volts. Was my average. Okay, and that was going through the resistor. And since the resistor was the only circuit element in my circuit, then that is the power coming from the iLab device. Okay, remember that the breadboard and the wires have effectively no resistance. So it's all coming, it's basically all the power is just going through the resistor. Okay, and so that's the reason why you have this port called 3.3 volts. So you should be getting very close to 3.3 volts is the power source coming from here, okay, or your voltage provided by the iLab device, okay? And then in figure 3 in the lab manual, you'll see I have the voltage, I have the resistance. So but from that, you can calculate the current going through that resistor. Okay, and then in part 3, we're going to set up a series circuit. Okay, so we're in a series circuit. The current only, remember, has one path to flow through. Okay, so in order to do that, I'm going to take a second 10,000 ohm resistor, and we're going to, since we're just following one path, all right, well, I'll just take out my negative end to the battery connection for now, and then I'll put one end of the second resistor in row 9, right, where the one end of the first resistor is, and then I'll pop the other end of the second resistor in row 17. Okay, so that's our one path, right, going from this through this resistor, right, from the power source through the first resistor through the second, and then if I plug the negative into row 17, right, then the path continues through black wire to the battery, back out through the red wire into the resistor, and we have our one path. Okay, and so if we wanted to record or measure the voltage going through the second resistor, what I would do is I would move my A7 wire to row 9. Okay, because remember that the analog 7 sensor measures from the A7 port to the ground port. Okay, so now it's just measuring through this second resistor. Okay, so you can go ahead and record that in your software. Click record, get an average again, what's going through there. Okay, and then now what we're going to do is finally, one of the last things I think really in this lab is we're going to take one of the 1 ohm resistors and we're going to replace that second 10,000 ohm resistor with the 1 ohm resistor. Okay. And if you get mixed up, you know, you should have some extras so you could tell them apart, but essentially you could see that the 10,000 ohm has an orange stripe on it, and where the 1 ohm one doesn't have that orange stripe. Okay, so let's put it in the same spot as that second 10,000 ohm resistor. So now I have a series circuit with a 10,000 ohm resistor and a 1 ohm resistor. Okay, and now I want you to try to record the voltage drop across that 1 ohm resistor. Okay, so everything's still set up like it was before so that we can measure the voltage across the 1 ohm. Okay, so go ahead and try that, and you should see that you're going to have an issue with doing that. Okay, and the reason is because the iLab device, or this, not the iLab device, but this particular sensor on the device, the analog 7 sensor, is not sensitive enough, okay, to actually measure the tiny amount. So if you think about it, we have a 10,000 ohm resistor and a 1 ohm resistor, okay? And so remember, in the series circuit, the current flows through one path, so the current's the same everywhere, but the voltage from the power source gets split up, okay? So if we have a 10,000 ohm resistor and a 1 ohm resistor, that means that 10,000 times more voltage is going to the 10,000 ohm resistor than the 1 ohm resistor, okay? So it's really tiny, the amount, okay? And you can calculate that. So I want you to calculate that and put that in your lab report. And then in order to actually find out what that voltage drop is across the 1 ohm resistor, we can use a different sensor on the iLab device. So I'm going to click reset a couple times to clear everything, and that will allow me to choose a new sensor. This one's called the high gain sensor. Okay, and you see that showing up, and I'm back to under dongle ID, it says it's paired, right? So if I look at the iLab, the lights went off, okay? So after several minutes without using it, what you notice is that it shuts off automatically. So that happened, that probably will happen to you. So just turn it back on, and then now we have our graph there. And what we see here is the units in parentheses here are MV, right? They're for millivolts, okay? So that's what this is measuring, right? The analog 7 measured full volts, regular just volts. This is measuring millivolts, so it can read up to 1 millivolt, so tiny amount. So we can try to use this sensor to measure the voltage, that tiny amount of voltage going through that 1 ohm resistor. Okay, so what I'm going to do is I'm going to take the green wire from my green wire out of the A7 sensor, and I'm going to plug it into the high gain. The high gain sensor has 2 ports. Okay, it has G plus and G minus. Okay, so that's the high gain sensor. So I'm going to plug the green wire into the positive end, the G plus. Okay, because remember that on our breadboard in our circuit, right, the power is coming from this end. Okay, so I want the plus to be on the same end. Okay, and that's how it'll be in a full circuit. And then what we'll do is I'm going to take my last wire, my last jumper wire, our 4th one, and I'm going to plug it in to the other end of the high gain sensor, the G minus. Okay, and then I'm going to plug that into row 17. Okay, that's the row, right? That's the row of the other end of the resistor. So now we're measuring across the 1 ohm resistor, okay? From one end to the other end. Okay, and when I do that, if I click record, I'm going to get a certain amount, okay? And so I want you to get this amount, click and drag, get an average, and put that in your iLab or your lab report, okay? But the high gain sensor has a little, needs a little calibration. It doesn't work perfectly. It's has what we call an offset voltage. And so this is not giving us the exact perfect amount. So the trick to getting around that is all we have to do is we're going to take a second measurement and then average the two. And that will give us the actual voltage going across that 1 ohm resistor. Okay, so to get our second measurement, what we're going to do is we're just going to simply flip the direction of the high gain sensor wire. So I have for mine, I have the white wire going to G minus, the green wire to G plus. I just flipped them. All right. So I'll put the green wire in G minus, white wire in G plus. Okay, so it's just reversing the direction of the measurement. Okay, and that'll be our second measurement. So when I go and click continue, you'll see it drops and it goes to a negative number. Okay, and it's not going to, you'll see it's not going to be exactly the same. So I have about 0.4 for my first measurement and about 0.3877 for my second. All right, so you can click and get an average of those two. Right, so average for measurement 1, average for measurement 2, and then average those two numbers. Okay, don't worry about the fact of the negative here when you're doing your average. Okay, just add the magnitude. Okay, so for me, I would add 0.406 millivolts. I would add that to 0.387 millivolts and then average the two. Okay, and you probably get something slightly different, but that's okay. Everything is not perfect and the same everywhere. Okay, and then finally, now that we know the voltage through there, you can calculate the current going through that resistor. Okay, so you can I want you to calculate the current. Now that we know the voltage, the tiny amount of millivolts going through there, calculate the current going through the 1 ohm resistor. And since the current is the same everywhere in a series circuit, then we know that it's not just the current passing through this resistor, it's the current everywhere. So it's the current passing through this resistor. Okay, so this is an interesting application. When we throw a 1 ohm resistor in series with something else, because when you calculate the current is voltage divided by resistance, and since our resistance is 1, okay, then basically our current I, right, is V over R. So V over R or V over 1 is just V. So your current and your voltage are going to have the same magnitude. Okay, anytime the resistance is 1. Okay, and so basically what we did when we got our average here of current of the millivolts, okay, if say it's 0.4 millivolts, okay, is the voltage, divide that by the 1 ohm resistor, 0.4 divided by 1 is still 0.4. So 0.4 then is not only the voltage, 0.4 millivolts is not only the voltage, but 0.4 is also the magnitude of the current. Okay, so if we have a reading of 0.4 millivolts through a 1 ohm resistor, then the current is going to be 0.4 milliamps of current. Okay, so kind of make sure you do that out yourself, do the math out yourself, read what I wrote in the instructions. Okay, make sure you understand that well, because we're going to do this again many times. Okay, so basically what we did by putting a 1 ohm resistor in series with a giant resistor in comparison, 10,000 times larger, right? The voltage, pretty much essentially all the voltage goes through the 10,000 ohm resistor, and the 1 ohm resistor, that voltage is basically negligible. Okay, so by just popping that 1 ohm resistor in there, that allows us to effectively measure the current going through that 10,000 ohm resistor. Okay, so we've effectively created an ammeter. Okay, an ammeter is a device that measures current. Okay, so really what we can say here is that this 1 ohm resistor is essentially an ammeter. Okay, and so that's how we're going to measure current in our labs. So make sure you understand it's a little bit trickier to do, but after you try it a couple times, get to understand it, it'll start making more sense. Okay, and that's it for the circuit basics lab.